Hey Algebra 1, here are your notes for 10.4 day 2, talking about the quadratic formula. So we talked about this in yesterday's lesson, but there's a little bit more to it, and I just want you to get a full and complete idea. So, suppose you want to solve 12x squared plus 7x equals 15 using the quadratic formula. What is the first thing you should do, especially with this example? Well, since it is not in standard form, we need to set to 0, and I'm going to put in standard form. Now this should come naturally when you move the number over. However, I just want to remind you that it needs to be in standard form in order for the quadratic formula to work. So what are the values you need to substitute for a, b, and c in the quadratic formula? Just like I had you doing yesterday, I want you to identify what each of those values are. I'm going to rewrite it down here just so we can look at it a little closer, but 12x squared plus 7x minus 15 equals 0. A in this case, remember a is always the first because it comes before the quadratic term. A is 12. B comes behind the quadratic term. It's the linear coefficient. And then, of course, the constant comes in last here, negative 15. Next, it says find the roots of the quadratic equation. Remember that roots, solutions, x-intercepts, because we know that they touch at the x-axis, x-intercepts are all code for the same thing. They all mean solutions. We want the solutions or the answers to that parabolic function. So let's do that. Now that we know a, b, and c, let's plug it in. X equals negative b plus or minus the square root of b squared minus 4ac all over, this should extend, all over 2 times a. Of course, when I simplify that, I'm going to get negative 7 plus or minus the root 769 over 24. Now, I said please usually keep these in this complex form. However, when you've got something that says 769 in the root, that's just awful to look at. So I'm going to throw that in a calculator and simplify this down to the two answers. So x, in this case, is approximately 0.9 and approximately negative 1.4. So those are our roots of this quadratic equation. All right, next up, can you use the quadratic formula for quadratic equations like this? Now, first off, you shouldn't. This is a difference of squares, and you should automatically go to your factoring that we've learned. This one would be factor out a GCF. But I want to show you that it can be done. The only problem is, because we don't have a linear term, this is not technically in standard form, and we need to rewrite it in a way that it has that linear term. One way to do this is by saying plus 0x and rewriting the rest. By adding a plus 0x, you haven't really changed anything because 0 times x is just 0, and adding 0 doesn't change it. But it does allow us to have a coefficient in order to plug in to our formula. It allows us to have a 0. So if I plug this into the quadratic equation, I'm going to get negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times 1, which when I simplify out is just 0 plus or minus root 196 over 2. And when I simplify root 196 and divide it by 2, I see that my two answers are going to be plus or minus 7. So, just like I would find if I had just done this using the difference of squares method, I find that using the quadratic method does get me the right answer. However, I think doing all of this is a lot of extra work, when we have the difference of squares method available. Same thing here. It's a GCF problem, but if we rewrite it with that constant term attached, we can still use the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a, and it equals 3 plus or minus, when I simplify everything in there, I get 9 over 4, and this simplifies out to 6 over 4 and 0 over 4. So my two final answers are 3/2 and 0. Just like that. Again, we can use it. I don't suggest it if you have easier methods. All right, let's jump to the back. Here are some special cases I want you to think about. And if we just complete these the same way we've been doing, we'll get some answers. So a is 4, b is negative 4, c is positive 1. Negative b plus or minus the square root of b squared minus 4 ac all over 2a. When I simplify this, I get 4 plus or minus the root of 0 all over 8, which then just simplifies out to 1/2. Now, why did I only get one answer here? Well, 4 plus 0 divided by 8 is half, and 4 minus 0 divided by 8 is half. What does it mean when we only have one solution with a parabolic function? Well, I think it helps to graph it out. Normally, when we have a parabolic function, it crosses the x-axis 2 times. However, this one is a little different because it only crosses once at 1/2. Because it's a positive, what this essentially means is my parabolic function is going to come down, touch at that point, and then go back up. One solution, one root, one x-intercept, and it's right there at 1/2. All right, let's go to the next one and see what happens there. I have a is 1, b is negative 9, c is 22. All right, b plus or minus the square root of negative 9 squared minus 4ac all over 2a. All right, simplify that out. I get 9 plus or minus the root of negative 7 over 2. All right, problem, people. We don't know how to deal with negatives inside of square roots yet. Because this can't be done, and because we're not in Algebra 2 and we don't know how to deal with that, we technically don't have any solutions. There are no solutions that work for this. So A is no solution. Now, because I can't simplify and there's no solution, what does that mean for our graph? What does it mean when a parabolic function does not have a solution? Well, remember that the solutions of a parabolic function are wherever our function crosses the graph. If there are no solutions, that means that wherever our line from our function comes down, it never quite reaches it. It reaches it somewhere up here. So there's never a x-intercept and therefore not a solution. And we have a shortcut of figuring out how many solutions we're going to have. What part of the quadratic formula defines whether or not we'll get real solutions? Technically, this is a complex or a non-real solution for those of you who are interested and curious about Algebra 2. So the part of the quadratic formula that defines whether or not we'll get the real solution is what is inside of the square root. So x equals negative b plus or minus the square root all over 2a. And I'm going to put this in a different color so that you know exactly what I'm talking about. b squared minus 4ac. This piece inside is called the discriminant. And that discriminant tells us how many answers or how many roots that we'll have. And how does it do that? Well, if your discriminant, b squared minus 4ac, is greater than 0, you're going to have two solutions, or two roots. If b squared minus 4ac is equal to 0, you're going to have one root. And if b squared minus 4ac is less than 0, you're going to have no real roots. Now, why is this? Well, let's think about it in terms of a square root. If you have a positive number in a square root, you have the positive and the negative version of that square root. That's two answers. If you have a 0 in your square root, what's the square root of 0? It's just 0, so you'll only have one answer. But just like this example, if you have something that is less than 0 in that square root, i.e. a negative number, it makes sense that we can't take the square root of a negative, and we're not going to have any real answers. So, how will we know when we only have one solution? Well, that is when the square root or discriminant, this is the technical name, so try and put that vocab word away for your brain. Discriminant is 0. So, discriminants can be very, very helpful. And they tell us a lot about specific solutions. We're going to talk about this more in Algebra 2, where we start learning where this goes. Technically, it has no root right now, but eventually we'll start talking about the fact that it has a non-real root. That's coming into imaginary numbers, so look forward to that when you get to Algebra 2. If you have any questions on your homework, per usual, let me know. I'd love to help you out.